All right, so my name is Dinah Ford. I'm the lead researcher in education at Unity. For those of you who don't know, Unity is a game engine company, and 90% of the content created across a lot of industries are made using Unity, from healthcare all the way to automotive. Today, I'll just kind of focus on augmented reality games. Specifically, my presentation is entitled Using Augmented Reality to Enhance Gameplay. We always want to use technology to enhance. And so I want to focus on some research and findings from running the first augmented reality class at UCLA in the computer science department. Hopefully the lessons learned would be how to create more advanced AR applications, and specifically more advanced AR games. So our goal in the class was how to use AR to enhance gameplay, and specifically we wanted to focus on this transition, jumping backwards and forwards between the real world and the virtual world. And so one of the biggest challenges that we knew we were going to face is how do we create rich gaming environments? And to do that, we knew, because we are in computer science, that we want to tackle it from a technological perspective, so we needed to create feature-rich environments. And so we were constrained to using Unity and the Vuforia API. And so this course was held just before the release of the HoloLens. And so I still think it's super applicable, the findings and our research super applicable to both wearables and tablets, because I don't think that the industry has, the AR industry has realized its potential in terms of creating rich gaming experiences. And so just kind of I'll describe a little bit this example to get us going. What you see is a tracking algorithm is used here in this game, one tracking algorithm, and to track one image. And as a result, we have superimposed 3D models. And we don't think this constitutes a rich gaming environment. So we wanted to do something about that. So before I get into it a little bit more and talking about the technology, we kind of need to address what constitutes a rich gaming environment from a gaming perspective. And to do that, I would just kind of want to give a quick run through of a breaking down of a game. So we'll do that with another example. So we're going to use this game to and we're going to break it down fairly quickly. At the top, first we see a can of Coke. This is our environment. At the top, you see a princess. So we have some characters. We have some suitors, good guys and bad guys. The role of the player, as you can see, it can move around, so there's a number of different perspectives you can see this from. And the role of the players to kind of prevent the bad guys from reaching the princess first. You can see a heads-up display, so where the points are being kind of tallied up and displayed. And this, altogether, the rule of the game is to save the princess. And this, on its as a whole, constitutes a complete breakdown of any game. So you can generalize across the board. You now can make a game. Seriously. And so if we kind of take this breakdown and kind of want to summarize, what are the two most important things about this that are going to make it or break it for us to enhance the gaming experience? And we can see one is interaction, the player's interaction with the game, and the second is the element of control they have over the gameplay and the characters. And so we thought, all right, so now we've talked about gameplay, we know what we need. Let's kind of go back to this technology problem. We know that the HoloLens is an out-of-the-box solution for creating rich environments, rich gameplay. Why not just, what do they do? They, why is a rich environment? They use real-time tracking. They use sensors like GPS. So we thought, why not do that? Let's make our solution a similar solution. Let's use sensors to extract useful data, and with that, improve tracking. So as you can see in this game, we're using a GPS to track real-world environments, in this case, the UCLA library. And pretty sure you're familiar with this format, this game genre format now, having Pokemon Go, the Pokemon Go explosion in the market. So, but it wasn't familiar when we came up with it, I promise. It was new. All right, so we ended up doing this, and in the process of using those sensors, we're collecting a lot of information. What we started noticing is that we're moving towards actually recreating real life and mimicking real life in the virtual world. So we got to the stage that we were like, all right, actually tracking needs to work, and that's not the bottleneck for enhancing gameplay. What we're really doing is we're creating accurate models, and in this instance, the students created a geometry. They recreated the geometry and the environment in the virtual world to enhance the gameplay. And so our results really showed that creating accurate models of real world enhances gameplay. And so I'll give another couple of examples. In this one, what you see is a game. It's a puzzle game. Multiple sensors were used to record the pose, the player's pose. And consequently, as the player moves around, different types of geometry are rendered to the screen. And therefore, they need to move in certain specific positions so they can piece the puzzle together. And this is the type of gameplay that you cannot achieve using just any game, just normal desktop. You can't render on normal desktop. And so with novel experience of using AR. Another example would be using accurate kinematics to gain better control of your characters in the virtual world. And what you see on the screen is a virtual hand, a representation of a real hand, and we're using the leap motion controller. Now, when I showed this yesterday, I was completely surprised because I didn't get any wows. It was like, oh yeah, that's cool. We've seen virtual hands before. It's like, I just want to point out today that this is not wearable hardware. This is a cell phone, right? And then now we've achieved on a cell phone, we've taken inputs out and we're using real hand maneuvers in AR. It's not VR. So, and this is happening in real time. So for us, it was like a big wow. And the closest thing I've seen to this is now is Meta. If you've tried Meta, they're doing things with the hands. And of course, if you've used the HoloLens, you know that they're still doing this. You're not using your hands. And so we were super excited that you have complete, accurate, full control on your cell phone and jumping up and down. So yeah, I just wanted to point that out. So thank you. All right, so we're doing all these things where we're collecting, we're recreating accurate models of interactions, real environments, geometry. What were the issues? Of course, it came down to the sensors. Now the sensors, we're relying on the sensors to collect this accurate information. And if we notice that if we're using any internal sensors from tablets or cell phone, they're inaccurate. So we had to kind of move over to using external sensors. So let's talk a little bit about the implications of this work. So we've had, we ended up with 18 games. Each one of the games they created an accurate model of either, again, geometry, environment, interactions, kinematics, or focusing on using the accuracy of the sensors. And so coincidentally, these 5 models that I just listed are prerequisites to creating robotic simulations in game engines. So we got super excited that our research paves the way and opens a lot of room to exploring human-robot interactions, which is a huge problem that we will need to tackle soon enough as we're progressing and as we're growing AI and machine learning, both fields, right? The AI and machine learning and the robotics field. And so, yeah, fun prediction right there, and thank you so much.
Right, we have